Chapter 3, The World of Numbers. End of chapter exercises. Let's have first question. Convert the following rational numbers in the form of a terminating decimal or non-terminating and repeating decimal, whichever the case may be, by the process of long division. First example, 3 by 50. In the 3 by 50, here denominator 50 is more than 3. So while dividing 3 by 50, we have to first divide it with the help of 0. 50 zeros are 0. So 3 minus 0, 3. Take decimal, it becomes 30. Now again 30 is less than 50. Again 50 zeros are 0. 30 minus 0, 30. With the help of decimal, it becomes 300. 56 are 300. 300 minus 300 is equal to 0. Since the remainder is 0, it means the decimal expansion of 3 by 50 is terminating decimal. Therefore, 3 by 50 is equal to 0.06. Next example, 2 by 9. In the fraction 2 by 9, 9 is more than 2. So first 9 zeros are 0. 2 minus 0, 2. Take decimal, it becomes 20. Now in the table of 9, 9 twos are 18. 20 minus 18, 2. Again we reach to the remainder as 2, which is first here as a dividend 2. It means this process will be continuously going on. That is, the decimal expansion of 2 by 9 is 0.22222 and so on. That is 0.2 bar. Now we have some definition and one result. To prove any number of the form square root 5 is irrational or square root 7 is irrational. For that we should know the definition of divisibility. An integer b is said to be divisible by an integer a which is non-zero. In symbol we can write this as a divides b or b divided by a. Both have same meaning. How we are writing often? B divided by a. So in higher mathematics this means a dividing b or a divides b. Here we can read like this, a divides b. So both has same meaning. So when we say that the divisor a divides the dividend b, if there exists some integer c such that b is equal to ac. So whenever a is dividing b, then the dividend is equal to divisor into some integer c. If the product of a into c is same as the dividend b, then we say that b is divisible by a or a divides b. For instance, suppose we have this example, we have to check whether 18 is divisible by 3 or not. So for that, this is dividend and this is divisor. So by definition, there exists some integer, say k, such that 3 into k, that is divisor into that integer k, is equal to 18. So what could be the integer? K equals 6. So if such integer exists whose product with divisor is equal to dividend, then only we say that 18 is divisible by 3. One more important result, for any prime number p, if p divides a square, then p divides a. For example, 5 is dividing 25. 25 means 5 square. What should it imply according to this result? 5 will divide 5. Or any other example we can take. Suppose 2 dividing 8 square. It imply 8 square is what? 64, and 64 is divisible by 2. It implies 2 should divide 8. Here p is a prime and a is any other integer. So this is also important result. Now in this case, when 2 is dividing 8, so with the help of this definition, when we say that 2 divides 8, if the dividend, that is 8, is equal to 2 times some integer, that some integer should be 4. So here, whenever p divides a, it implies a is equal to some integer pk. This is the thing. Now let's have proof. Next example, prove that square root 5 is an irrational number. To prove square root 5 is an irrational number, we will assume that root 5 is not an irrational number. If it is not an irrational number, then it has to be rational number. So let's assume root 5 is a rational number. Then there exist integers p and q having 1 as the only common factor, such that p by q equal to root 5. Because we are assuming root 5 is not an irrational, so it is rational number, and rational number root 5 can be written in the form of p by q by definition, where this p and q are in reduced form. In reduced form means that p and q has only 1 as a common factor. P and q have only 1 as a common factor. By definition of rational number, p by q equal to root 5. Now squaring on both sides, if we square on both sides, then p by q whole square is equal to root 5 square. This implies p by q whole square means p square upon q square, and root 5 square is 5. So we have p square by q square equals 5. Now this implies p square is equal to 5q square. How? Multiplying on both sides by q square. So if I multiply here by q square and here by also q square, then what happen? This q square get cancelled. So remaining p square is equal to 5q square. We call this as equation 1. Now by the definition of divisibility, if b is equal to ac, then what it implies? Either a divide b or c divide b. So here we have p square is equal to 5q square. It implies 5 divides p square. By that result, whenever p dividing a square, we have p divides a. So using this result, as 5 is dividing p square, so this implies 5 divides p. Again, by definition of divisibility, we are saying that when b is divisible by a or a divides b, then there exists integer c such that b equal to ac. So as here 5 divides p, there exists integer k such that p is equal to 5k. Now we have to put this p equal to 5k value in equation 1. So here we have to replace p by 5k. So what is equation 1? P square equals 5q square. Now put here p equal to 5k. So 5k whole square is equal to q square. 5k whole square and q square. Taking square root on both sides, we obtain 5k equals k. Again, use this definition of divisibility. Whenever b equal to ac, then a divides p. Now here we have q is equal to 5k. Imply 5 should divide k. So thus by this definition, 5 divides q. Now if you observe here, here we have 5 divides p and here we have 5 divides q. What it implies? It implies 5 divides both p and q. If p and q both are divisible by a same number, that is 5, it means that number has to be factor of p and q. So it means 5 is a factor of both p and q. But this is not possible. Why? Because here we assume p and q having 1 as the only common factor, and here we obtain 5 is the common factor of p and q, which is a contradiction, which is not possible. And this contradiction arises because we assume root 5 as a rational number. So our assumption is wrong. Why? Because p and q have common factor as a 5. This contradicts our assumption that 1 is the only common factor of p and q. Thus our assumption become wrong. Hence root 5 is not rational number. It means root 5 is irrational number. So this is the solution for root 5 to be irrational number. So only that definition of divisibility you should know, and the result. If P divides A square, then P has to divide A. Thank you.